All right. So then let's step through this. Can somebody name for me the factoring methods we have so far? What's the very first? Go. GCF. And try and name these in order, because this is the order where you're going to actually do them. What comes after GCF? Go.
Is it unfoil?
Unfoil. What comes after unfoil? Rosie? Binomial squared, correct. What comes after binomial squared? Brendan?
I was going to say grouping.
That's fifth. What's the one right before that?
I know.
Yeah.
Difference of two squares.
Difference of two squares.
Whatever it is.
That's right. Difference of two squares. What's the fifth method? Let me see. Andy? Grouping. And then what's the sixth? We have not studied the seventh yet, but what's the sixth so far? Go ahead. Magic pair. The one we're doing now. To refresh my memory, some of these are kind of trick questions and some of these are not. When can you use GCF? Go. Anytime at all. There are no restrictions on it. For unfoil, when can you use it? There's a code for it. Go.
Is it
3, 2, 1. What does that mean? 3 what? 1, 2 what? 1 what? Sure, why not? 3 what? Just do one. 3 terms. Jonna, what does the 2 stand for unfoil? 3 terms.
Wait, 2? Like the, isn't it an exponent?
Yes,
Right?
highest power, degree.
Oh.
So the 3 terms, degree of 2, and what does the 1 stand for? Here. For unfoil.
Is it the highest number in front has to be?
The number in front. The number in front of the x squared. The number in front of the highest power thingy, yeah, it has to be 1. In other words, the lead coefficient has to be 1. So 3 terms, degree of 2, and a 1 in front. Otherwise, unfoil does not work. Binomial squared. Can somebody name me the 3-step pattern for a binomial square? Mary, help me out there. How do you square the first, double the product, square the last? Exactly. Number 4, difference of 2 squares. When can you use that? Jack Hill. Two terms, they're both squared, and what in between? For difference of 2 squares. Subtraction. A square minus a square. Difference of 2 squares needs a square minus a square. How about grouping? When can we use that? Maria? Parentheses have to be the same, and how many terms do you need in order to start it? 4. You have to have 4 terms. The two are grouped together, 2 are grouped together. And when you get the little mini GCFs, the parentheses have to be identical. Magic pairs, I remember the code for that. It's very similar to unfoil, but with one difference. Go, Brent.
Well, it's well, you can have 3 terms. Well, you have to have 3 terms. 2.
Starts with a D.
2 degrees.
Degree of 2.
And there's no special condition.
Correct. 3, for magic pair, you can say 3, 2, any. 3, 2, any. Yeah. Yeah, right on. Now, how do you start magic pair? So I suppose I should ask first. Is there a GCF on this one? Maybe? What do you think?
No.
No, there's not. Can we unfoil it?
Well, I was gonna say, be sure for the first and the last one. You ask the
Correct.
question.
Actually, let me get back to, I'll ask you that in a minute. Can we unfoil this? Josh, can I use unfoil? No, what's wrong? I got 3 terms. Highest power is 2, that's good. What's not right? Go ahead.
It doesn't have a coefficient of 1.
Doesn't have a coefficient of 1. It has to be a plain old x squared. Now, somebody at my previous school said, Mr. Goggins, there's a 1 in front of the 12. No, that's not what I'm talking about. It's 1, 1, 1, just plain old 1. It's not part of 12. So if it were plain old x squared, we could try it. But here, not so much. Binomial squared. Could my fault? Sorry. Can binomial squared work here? Right. What's the pattern for binomial squared again? 3-step pattern.
Double the first.
Square the first.
Double the second. Square the
Double the what?
Double the second.
Not second, but very close.
Product.
Product. Nice. Square the first, double the product, square the last. Does it look like this is the result of one of those? Definitely not. The -5, horrendous. I dare you to find 2 numbers multiplied to get 5. Well, I suppose you could. But multiplied to get -5? Wrong one. 12, half good, half bad. This isn't even a great double product. I suppose you can get 0.5x. But I suppose. But this is disaster area. Question?
Is there a number times itself that equals 75?
Yes. It's icky. It's the square root of 75 times the square root of 75. I know that she did. What's the square root of 75? 8 point something. I don't know. You'd have to use a calculator to get the decimal approximation. I can't do binomial squared. Can I do difference of 2 squares, Eric?
No,
Why not?
because there's more than 2 terms.
Right, more than 2 terms immediately disqualifies. Difference of 2 squares has to be a term squared minus another term squared. And this is nowhere near. Can I factor by grouping, Rob? Why not?
Because there's 3.
There's 3 terms and they're supposed to be what? 4, correct. So there's only one choice left. So, Josh, what do I do first?
Circle the first and the last.
Okay, and then what do I do?
Did you find out the terms?
Kind of, sort of, but I have to do something first with these 2. What do I do with them? I do what with them? Yeah. Multiply them. Go ahead and do that for me. What's 12 times -5? Exactly. -60 x squared. Draw a line under that. So the first step is circle the first and last terms and multiply them together. So you're going to get a bigger term. So, now what? Yeah. Right. You want to get balanced factor pairs. So I don't want to split it into 5 things, and I want to make sure they're balanced, which means each of them has to have a what? Okay. An x. I would start small. 1x times something. Talk me through this. Where is it coming up? 1x times what? -60x. Does 2 work?
Yes.
So 2x times? Okay. Would 3 work? Times what? I'm going to stop there for a second. It goes on. It keeps going on. How do you know when you've hit the right pair? Andy? How do you know when you got the right pair?
Well, if they add together,
They equal the middle term. In this case, we want to add up to make what? 17x. Let's just check these while we're going. I deliberately stopped this for a reason. Just curious if anybody sees it. Yeah.
It's 20 top plus -3.
What do you get if you add those?
What? 17.
Almost.
I said 20 plus -3.
Ah. So what's this sum right now?
It's, wait, what?
If you added these 2, what would you get?
-17.
-17x. Let's do the other ones while we're at it. Let me see. Go ahead. Add these up. What do you get?
That would be -59x.
Okay. And then how about this one?
-48x.
See what's happening? So this one, it's nowhere near. This one's nowhere near. This one may be stopping my tracks. Say, whoa, oh, so close. Is there a shortcut for this now? Go through the text. What are you gonna jump down to?
Negative 3x.
Yeah, 20x times negative 3x, swap places. That'll give you positive 17x. And that's exactly what we want. So if you see something that's the exact number you want except it's the opposite sign, hyper warp down to the other side, switch the signs of the two, and you got it. So next question, what do you do with it? What's its purpose? Yeah, me. Yeah, where? Plug it in place of 17x. I do have to change one little thing in order for it to fit. Let me see, Mary. What do I do in here to make it actually equal to 17x? Add them, correct. Can you give me this from beginning to end? Plug that in.
12x squared plus 20x plus negative 3x plus
Good, plus negative 5. Does everybody see where we got that? So instead of the middle term, I plugged in the magic pair. I'll do it. Why would you do that? It looks even worse now. There's 4 terms. Gosh, what do you think? What method might work now? Grouping. Grouping means you check the first pair and the second pair, and don't capture the plus sign. Is there a little mini GCF that works with this one? John, give me the first one. Is there a number that goes into both of these? What's the biggest number that divides into 12 and 20? 2 works, but there's a little bit bigger. 4. Do they have anything else in common? The x. Now take over Maria. What's left behind if you pull out 4x?
And
5, exactly. Give me the next one, Rosie. Does anything come out of here? Negative 1. Again, I'm not very wild about the 1, but I had to pull out a negative because the first one is negative. And what's the leftovers?
3x plus 5.
That I'm interested in. Is this going to work?
Yes.
Yes. What makes you say that?
Because
Parentheses are the same. What do you do with it then? Yeah, Jacker. Take over. Yeah, pull out the 3x plus 5. Pull it in front. So 3x plus 5. And then give me another parentheses for leftovers. 4x plus negative 1. You're done. Yeah.
Does the last term have to be just a number without a variable?
Does the last term have to be a number without a variable?
No,
In the original one? Ah. I think I know what you're talking about. Could you have something like this, you mean?
No,
Without a number?
Something like it has 3 of them, but like the last one also has 2.
Oh, I see what you're saying. In order to have a third term that's not a number, you'd probably have to start with x cubed. And then that would spoil the 2.
Yeah.
Yeah. So now the only exception I know of, if somebody had done this, 12x cubed plus 17x squared plus negative 5x. Now, would grouping? I cannot. Would magic pair work on this? No, because it's 3 terms but not a degree of 2. But does anybody see the catch? There's something you can do first. Like if I actually gave this to you on a test, you could do it. Yeah. There's a GCF of x. 12x squared plus 17x plus negative 5. And then that stuff you can factor. So if you actually did this in real life, it would look like, I'm just going to cheat because we already did the work. 3x plus 5, 4x plus negative 1, and you're done. So could you use magic pair eventually? Yeah, but only if this got down to a regular number. If that makes sense. Any questions so far? Does this make sense? Doing okay on this? All right. You have roughly 35 minutes. Some of these are going to take a little while, so pace yourself. but this is due tomorrow, in class 65 in its entirety, so the whole thing. And for those of you listening at home, in class 65, this is Wednesday, so in class 65 is going to be due on Thursday, September 30th, and we'll talk to you later. Take care. Bye-bye. Somebody get that read.